everyone. Today's lesson is going to be on coordinate planes, and we're going to have our learning goals still be in terms of solving 1- and 2-step equations. We're just going to be able to take those equations and graph them on a two-dimensional space. So you should have your template. The large component of your template, the L-shaped component, should be pasted to your page for your notes. The small, kind of coordinate grid, which is this piece here, is actually going to be part of your proof. So you don't need to paste that onto your main page. We'll paste that over where our proof problem is. So this is just a basic fill in the blank to give you some vocabulary. What we're going to do is go through this together, and then I'll ask you to do a few plotting points for your proof problem. So the first scenario here is really that a coordinate plane is made up of two number lines. The vertical number line is called the y-axis, and the horizontal number line is called the x-axis. And I always think of the y-axis being the vertical line because if you look at a capital Y, it does have that vertical stem that comes off of it. So I try to keep that visual in my head so that I think that this is the y-axis. And then obviously by default, the horizontal line is the x-axis. Both of those are number lines. They can be written with intervals of 1 or other intervals. So for example, when I looked at this number line, I could think that this is 1, 2, 3, 4 all the way across. Or I could think it's something like 5, 10, 15, 20, right? Just like we're doing a normal graph, the scale is important. So it's not always 1 unit. In this case today, we'll pretend it's 1 unit, but we're not actually sure because it's not labeled. The other thing that we should know about the coordinate plane is that it's made up of 4 quadrants. A lot of people have experience with quadrant 1. What that means is that if there's a 0 in the middle, quadrant 1 has positive values both to the right and vertically. So when I label this axis, it looks like 1, 2, 3, 4. I'm increasing with positive digits, right? Quadrant 2, on the other hand, has positive values on the y-axis, but negative values on the x-axis. So when I look, I do have, when I go to the left, I do have -1, -2, -3, -4. So this direction is negative. Quadrant 3 has 2 sets of negative values. So not only is the x-axis negative, but also when I go down the y-axis, it's negative. And then lastly, quadrant 4, as you can see, the y-axis is negative, but the x-axis is positive. So when you think about plotting coordinate points on the plane, anytime you see a positive and a positive, it's going to be in quadrant 1. When you see a negative and a positive, it's going to be in quadrant 2. A negative and a negative is quadrant 3. And a negative and a positive is quadrant 4. So it's important to be able to identify which quadrant you're in and why that's important. So the middle point, the very center of our graph, the 0, 0, is called the origin. It's just a special name for that location on your graph. And down here it gives us an example of what is called a coordinate point. And in this case, the coordinate point is measured first by the x value and then by the y value. So in this particular situation, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces over to the right. So my first value is 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces down, so my second value is -9. So this coordinate point, the location of the point is determined by the spacing on the graph, and when I look at this coordinate point, I can say that it's coordinate 9, -9. The first number is the x-coordinate, so it's how far horizontally the point is, and the second number is the y-coordinate, so it's how far vertically the number is from the origin. We're always starting at the origin and working our way across, either left or right, and then up or down. The second part of this particular lesson talks about ordered pairs and an ordered pair set, right? So several points here, is actually called a relation. And you can kind of think of the X and Y pairs going together. They're all related. So when you have a set of all those pairs, it's called a relation. The domain of the relation is all of the X coordinates. And it's important to keep in mind that when you label X coordinates as a set, you're starting from least to greatest. So you might want to jot that down so that you keep that in mind. And then the range is all the Y coordinates. Now the range is a little different, and we'll talk about that. So the domain of the relation is all the X coordinates, and what I want to do is list them from least to greatest. So when I look at my list of coordinates up here, the smallest X value is 1, and then I have 2, 3, and 4. They made it nice and simple for us. They just put it right in order. The range of the relation, or the set of Y coordinates, actually has to go in an order that corresponds with the X coordinates. So when I look at the domain, I see my first number is 1, so I want to look for the range that goes with the 1, which is 7. The second number in my domain is 2, so I'm going to go look at the range that goes with the 2, which is 3. And then 3 goes with 0, and 4 goes with 5. So as you can see, the range is not necessarily in order from least to greatest, but it corresponds with the domain. So we'll do one more example like that. The domain and range of this relationship. The domain, again, they're all the X values from least to greatest. So that means I'm looking at all of these X values. The smallest actually being -1. So -1, and then after that 0, and then 2, and then 3. So when I list the range, it has to be in the order that corresponds with those numbers. So to go with the -1 is the 8. To go with the 0 is the 12. To go with the 2 is the 7. And then to go with the 3 is -4. So clearly the range is not in order from least to greatest, but those pairs, when I line them up vertically, go together. So that's why we want to list them in that particular order. In terms of your proof problem, you can paste that last square with your coordinate grid onto your paper, and you're going to go through and you're actually going to plot those points for me. Remember, you always start from the origin, which is the middle at point 0, 0, and you count either left or right first, and then up or down. You might want to look at your notes to confirm which directions are positive and negative. And when you plot the point, please also write down the letter. So for example, the first point that I have on this paper is point A, and the coordinate is 3, 2. So I could plot 3 points to the right, 2 points up, and when I actually plot my point, I'm going to stick it there and I'm going to label it A. Right? So please make sure that you label it with the letter so that I can confirm that you put the correct point in the correct location.